Alkenes, alkanes, and alkynes. Then the next thing we can look at is cyclic and aromatic hydrocarbons. So just to begin with, what anything that cyclic is you have rings. So here saying no beginning, no end, that's just your fancier way of telling us that we're going to have rings instead. And because we have formulas, you can use the same formulas as you already know from looking at alkanes, alkenes, and alkynes. So starting off with, and usually with the rings, you'll see line diagrams. So that's just what I'm going to do here. If you have cyclopropane, you just have propane through 3 carbons and they're all connected. The word cyclo just means they're connected. So cyclohexane, hexane, same idea, 6 hydrocarbons, all connected. Now going into if you have a side group, and if you have a double or a triple bond. So if you have no side group, it doesn't matter where you start numbering your carbons because you have a ring and it would be the same no matter what. If you have a double or triple bond, the double or triple bond always are going to be between carbon 1 and 2. So we still have hexene, so 6 carbons. Place your double bond anywhere you want, and now that is going to be number 2, and it wouldn't matter if you numbered clockwise or counterclockwise. Once you've numbered your carbons, then you can place your side group. So on carbon 3, I want to put that methyl group. Looking at the next one, same idea is we're going to make our chain, so 5 carbons in the ring. And then when this part 1 ethyl, 3 methyl, here because you don't have any double or triple bonds, it doesn't matter where you start. So just start numbering your carbons anywhere you want. Now that it's numbered, go ahead and place those groups. So on carbon 1, you want that ethyl group, and on carbon 3, you want a methyl group. This last one, I love that I included this one, cyclodecene. Dec means 10. So when I draw this, because I'm not great at it, I just start numbering as I go. So 2, 3, 4, 5, 6, 7, 8, 9, oops, that should have been 9, 10, and then connected. So it's not perfect, that's fine. We can figure out how to draw this perfectly a different time. But now we have that shape. Again, your double bond is always between carbon 1 and 2. So since I've already had that numbered, I'm just going to add that in. And then I can place those side groups. So on carbon 5, we'll add that ethyl group. On carbon 3 and 4, you will put in those methyl groups. So that is the beginning. And then just an old diploma question that is pretty standard. We have our ring. It is butane. I know the options aren't here, so we'll just go over it. We want to know how to number it, how to name it. So when you are numbering, it doesn't matter again where we start, as long as you're giving your numbers the lowest number possible. So I am going to go 1, 2, 3, 4. But you also could have went 1 here and then 2 here, 3, 4 counterclockwise. But with my placement, actually that is what this one would have done. They would have went 1 over here, 2, 3, 4. Now with my placement, I have that ethyl group and methyl group. Well, now we have different groups. So E becomes before M in the alphabet. So you want to name this 1 ethyl, and then it would be 2 methyl, and then you could already tell that the first one's wrong because it's a ring. So you'd have cyclo and then butane. Sorry that we can't see those options there, but we would have had different options. We would want the one with cyclo, and then the other part looking for is writing those side groups alphabetically. So then going from here, the other part is drawing aromatics. And aromatics means you have a benzene ring. So if you have a benzene ring, you have that 6 carbon structure that's in a ring, and then you have alternating double bonds. And because we could draw this with our double bonds here, or we could have put them here as long as they were alternating, often instead now you see this drawing like this, and that has to do with the theory of how those bonds are shared, or those electrons. But right now, just getting into the naming, we're naming the same ring, same way, except now that if we do have a benzene ring, we don't need to write cyclo or anything like that. Same benzene will always be this structure. The other part though is if benzene is attached to a chain that has more than 6 carbons, then now it is now a branched group and you call it phenyl. So benzene with groups on it is a complicated and then says benzene. And if it's benzene on a long group, it is a phenyl group. So let's take a look at those examples. So this first one, 2,3 diphenyl nonane. So now because you have 9 carbons, which is more than 6, your benzene is a side group. So you can start by drawing that out with your 9 carbons. Again, line diagrams are just fastest, so let's do it that way. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then numbering from left to right. On carbon 2, you want to add a benzene ring, which is a phenyl group. And on carbon 3, we would want to do the same thing, adding that group. Now, the next one though, we have again something a little bit more complicated at the beginning, but then it ends in benzene. So we know that benzene is what we're starting with on our ring. It doesn't matter where you start to number, you just need to number in 1, 2, 3, 4, 5, 6. And then on carbon 2, you'll put that ethyl group. On carbon 1 and 4, you will put that methyl group. And then moving on, that is about it. We went over this, and then I would have assigned some homework from our textbook. If you are looking for some more, please do check out my website. It has all the lessons listed and videos are attached. As always, I hope you found this helpful. If there's any video I could do for you, please let me know. And thank you for watching.